take this idea. It is an idea. It's a theory.
One possible model. Yeah.
One possible model. We define some probes for this to prove it. Easy probes, inexpensive probes. Like for example, we said if the clock is going not to the sky, but deep down in the earth, what will happen?
If it's accelerator, it gets slower, yeah?
In general relativity, it will get not slower but faster.
Faster, because less gravity. Yeah.
Because there's less gravity, and the whole thing is about the force. In general relativity, it's a force called gravity, and therefore all of the things based on g. And g is less, therefore the time. So, basically, the quantum traction theory is easy to test. If we send a clock like deep down to the earth, and it doesn't count based on GR, and it's slower than what GR predicted, therefore this theory has the possibility to pursue further.
Problem is that maybe on 10 kilometers it is such a subtle effect that
they have good atomic clocks.
They
can actually measure it pretty easy.
Several kilometers.
Yeah, I think somewhere also in I don't know, Russia, they have like they dig a very deep hole, not that. Yeah, for another experiment, maybe someone can use it. The issue for this, we have two chances. First, logically, Albert Einstein says that I really like what he says. He says if you can define something simply, like you understood it properly, or if you need like very complicated description of something, then you are not in the right path. And he's right. Like a string theory with I don't know this much of mass and this much of very scientific explanation is one thing. This theory, by very easy and clear explanation about the issues like uncertainty, like the speed of light, the entanglement, is another thing. I think the key is in simplicity. Why I called it Barpa? There was a cartoon in 1970, Barpa. Okay, that cartoon is exactly represents the Fabrica system. What was that? Basically, there are some animals, kinda, and they could have any shape. They could go, they could come back, they could actually merge even to each other and create a system. Barpa was a very good explanation when this theory, I was developing this theory in my mind to show how Fabrica system works. This proton shooting one per day, or photon shooting, doesn't have proper explanation based on wave, unless you say you create one wave with one electron, and that wave, so basically the electron passes both these together at the same time, and creates a wave.
Self-interaction, this
self-interaction.
What physics says and official physics. It interacts with itself, that wave, one particle.
So basically one particle is interacting with itself. It doesn't seem logical to me. I know a lot of things are not logical in quantum physics, but we can start explaining both general relativity, again with correction, and quantum physics with this system pretty logically. They found illogical explanations because they couldn't explain it properly. I'm not a scientist, so I'm daring to say that. These scientists, they kill themselves sometimes to find, okay, this is the effect, so I should find the right way to explain it. Therefore, I'm gonna go to the extents that are sometimes totally illogical, and I will explain it with illogical how a particle is interacting with itself. So for sure, it should pass the double slit at the same time, and then interact with itself, right? And act as a wave. No, this is the right explanation in my mind because it has logic behind it. Every time that I'm shooting a particle, that is not the particle that is creating wave. The wave is the space, the shape of a space is changing completely to handle that particle. It becomes so expanded that it acts as a wave, and then it collapses when we observe it. And that is the shadow of collapsing the same similar shape space over and over and over again.
But is it so far your interpretation from that Copenhagen? But simply Copenhagen doesn't say anything about this cloud. It says I don't know.
This is Tablis interpretation as absolutely it is different from Copenhagen.
But you try to give explanation to this what happens before collapse. Yeah, before measurement.
Exactly.
And Copenhagen says we don't care. Yeah.
Exactly. They said we don't know where is it. That is uncertain.
Yeah, and we will not.
No, we know exactly where it is. This is the whole wave. It is where it is.
Sure,
but instead of one small, like a place in the space and time, that is the whole space itself, which is expanded.
Mm-hmm.
The space expanded that much, that big. Yeah. The space and time expanded. That's why when we collapse the wave in one side, the other side immediately will collapse too. Because the whole space and time collapse.
This is a problem of entanglement. Yeah, this is,
That is a problem of entanglement and no one can explain.
I would like to think more about entanglement. It looks to me more mysterious.
Yes, and it's proven. Like in lab, they proved it and still they have a problem with it.
Yeah.
Okay, so now.